In today's video, we are going to start a brand new topic called differential equations. But first, we do need to revisit something from way back in Algebra 2. My least favorite thing to teach in Algebra 2, but it comes back much more fun this time around. I'm going to talk about something really quickly called direct proportionality. You talked about this in Algebra 1 too, by the way. The amount of time it takes Priya to read a book is directly proportional to the number of pages in the book. What we're talking about here are two variables. The amount of time it takes Priya to read the book. Let's give that a name. We'll call it T. The time it takes to read. And another variable, the number of pages in the book. Let's call that N. And what you learned about in Algebra 2 was that sometimes these variables, these two different variables, relate to each other with what we call direct proportionality, meaning as one goes up, the other goes up exactly proportional at the same rate. And the way we would write that as a sentence, we would translate exactly the sentence it gave us. The amount of time it takes Priya to read the book is directly proportional to, means it's equal to some constant we don't know. We use K to stand for constant, obviously. Constant is equal to some constant times the number of pages. T equals K times N. And remember, T and N are variables. K is a constant, which means it's a value that can be found. T and N, they're not values that can be found. If some book will have 5 pages, some book will have 500 pages. So in some book will take an hour to finish, some book will take 2 hours to finish. N and T are not numbers that have specific values. They're variables that can take on any number. K is a constant. We can find that if we're given a little bit of help. So if a 200-page book, so if the number of pages is 200, it takes her 5 hours to read. We can use that to figure out what K is. K is equal to 5 over 200, or 1, if we reduce that to 1/40th. And so then we can figure out how long it takes her to read a 170-page book, because T is equal to 1/40th times N. And so if we replace the N with 170, we would say that it takes 17 over 4, or 4.25 hours. Fantastic. All I want you to remember from what you learned earlier is this idea of direct proportionality. Set that aside for a minute because we're going to talk about something else. Introduce a new idea called differential equations. The equation we just looked at is an equation, this one right here, that related two variables together. Most equations that we've dealt with forever have been equations that relate two variables together. A differential equation is really not that different. It's just that with a differential equation, there are going to be two variables that are related to each other, but one of them is going to be a rate of change of the other two variables. So let's take a look at an example which will clarify what I just said. So look at the first example. The speed of a car moving forward in a straight line is twice its distance from the start. So let's think about what variables we have here. We have the variable distance, call that D. We also have another variable that doesn't exactly show up here, but we're talking about a car moving over time, so it makes sense that time would be another variable to deal with in this problem. But then there is another variable that's discussed in this problem that's a little bit hidden, but it's there. It is the speed of the car, which is something we've been talking about all year long. We've just been calling it something else. We've been calling it derivative. The speed of the car moving forward is dd dt. That's the rate of change that I was talking about a second ago. Now, I understand that we talked a lot about speed and velocity, and there's other things to think about there, but we're not going to worry about that right now. We're just going to translate this sentence, the speed of the car moving forward. We'll call that dd dt is twice its distance from the start. dd dt equals 2d. That is an example of a differential equation. It is an equation that relates or defines the rate of change of one variable in respect to another using one or two of the variables that are changing. In this case, the only variable that it used was the y variable, the distance. Doesn't have to be. Okay, so we'll talk more about that a little bit later in another video. And slightly more generalized, we'll look at the next example, similar idea, the growth rate of a population of geese. So again, we've got that variable there is the population. I should really clarify that when I say the population here, I mean the number of geese in the population. And we're still talking about time, which is going to be a common theme here. And then again, that other variable is the growth rate. That's the rate of change of the number of geese. That would be dp dt. By the way, population, when it's used as a variable, is often referred to with a capital letter. I really don't know why, but that's just what you'll see most often. So if we translate this sentence, the growth rate of the population of geese, so dp dt, is directly proportional to the population, is equal to kp. Unlike the last example where we were told what that constant of proportionality was, we weren't told that here. And that's fine. We'll deal with how to figure that out in the next video.